Number 47. A phone company has a monthly cellular plan where a customer pays a flat monthly fee and then a certain amount of money per month, per minute rather, used on the phone. If a customer uses 410 minutes, the monthly cost will be $71.50. If the customer uses 720 minutes, the monthly cost will be $118. So we have part A here. Part A says find a linear equation for the monthly cost of the cell plan as a function of x, the number of monthly minutes used. Alright, so they've given us 2 points here, the minutes and the corresponding amounts of money that these minutes will cost in the statement of the problem. Those are 2 points, and these points are 410 minutes, and 71.50, or 71.5. So we can put the time first, as is usual, and then the cost for that time. And then we've got 720 and 118. Alright. So we can use the 2-point equation for a line. Y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Alright, so that's y minus 71.5 equals 118 minus 71.5 over 720 minus 410 times the quantity x minus 410. So we can focus in on the right hand side of the equation, reduce this fraction, simplify it. 46.5 over 310 times the quantity x minus 410, and that simplifies, the fraction simplifies to 0.15 times the quantity x minus 410, and distribute that through. You've got 0.15x minus 61.5. So then you add 71.5 to both sides of the equation, and you finally end up with y. You could call that y of t as well. Y is a function of, or rather y of x, if you want to do that. Y of x, that's y is a function of x, equals, or you can just leave it y, 0.15x, and then plus 10. Alright. And then we have part B, and it says, interpret the slope and y-intercept of the equation. Alright, so we can read it directly off this equation, this function. The slope is 0.15, which means, since we're dealing in dollars here, these prices are in dollars, that would represent $0.15 or 15 cents per minute. Alright, we're dealing with dollars and minutes, so the unit will be 15 cents per minute. So the slope is equal to $0.15 or 15 cents per minute. Alright, and the y-intercept is 10, which is must be the flat monthly fee, because the y-intercept occurs where x equals 0. Alright, so that's where the line, of course, crosses the y-axis. And so that occurs where x equals 0. And so, in other words, when you use 0 minutes, you're still paying $10, which means that's your flat rate. So, $10, Y-intercept is 10, let's see. So that's the flat monthly fee. Alright, and then part C. Use your equation to find the total monthly cost if 687 minutes are used. So just plug in x equals 687 into the function. Y of 687 is equal to 0.15 times 687 plus 10, and that equals 113.05 cents. $113.05. Number 49. In 1991, the moose population in a park was measured to be 4,360. By 1999, the population was measured again to be 5,880. Assume the population continues to change linearly. And so part A, find the formula for the moose population P since 1990. Alright, so here we go with part A. So we're going to let T equal the number of years since 1990. That'll make our function a little bit easier to handle. Alright. So that means we have the points. Well, you take a look at 1991, there was a population of 4,360, so that's 1 year after 1990. So we have the points 1 year after 1990, and the population with that was 4,360. We have another point, 1999, that's 9 years after 1990, so the T would be 9 there, and the population at that time was 5,880. So we have those 2 points, and we can use the 2-point equation for a line. Now we're using, they said to use population P, so that's the dependent variable. It depends on the time. The population depends on time. So it's the dependent variable, it's the vertical axis. The independent variable would be time, and that would be your horizontal axis. So this is a function involving the letters P and T. You would want to use those in the equation, those letters. All right. Of course, if it makes you feel better, you can use X's and Y's and then change back later. I think that's if your professor allows that. All right. But technically speaking, we should use P's and T's. All right. So we've got P minus P1 instead of Y minus Y1. And these are capital P's. By the way, in mathematics, capital P would be different from a lowercase p. All right, they would stand for different things. So you couldn't interchange lowercase with uppercase. All right, they are case sensitive, so to speak, in mathematics. That gives us more letters that we can work with. All right, because sometimes you run out. That's why they get into the Greek letters and everything else. Okay, so we've got P minus P1 equals, and capital P's here, P2 minus P1. And here we're dealing with t's now, t2 minus t1, lowercase. Time is often used in lowercase. Capital T's often represent temperature. Alright, so that's just the custom. And then we've got t minus t1 here. So there's our 2-point equation for a line using p's and t's. And so we've got p minus 4360. That's P1 there, and that's P2, that's T1, and that's T2. Alright, so that equals 5880 minus 4360 over 9 minus 1 times the quantity T minus 1. So we've got 1520 over 8 times the quantity T minus 1, which reduces to 190 times the quantity T minus 1, and distributing that through, you get 190T minus 190. Alright. And then you add 4360 to both sides, so you get P, or P of T, if you wish, equals 190T plus 4,170. Now, your book's answer is P of T equals 190T plus 4,360. Alright, that is incorrect. Okay, so be careful there. The book's answer is incorrect for part A here. So, this is the correct answer. You can double check my work if you wish. Go back over it. I've already double checked. Again, like whenever I disagree with the book's answer, I always assume it's my mistake, and I go back and I double check. Sometimes I triple check, and in fact, quite often I triple check. Alright, and finally I end up saying, well, either the book was right and I was half asleep, or the book was wrong. So in this case, unfortunately, the book's answer is incorrect. Alright, so watch out there. Don't let it frustrate you. These things happen. That's why they hire accuracy checkers and pay them good money to check books. Alright, so, and even they don't get all the errors. What does your model predict the moose population to be in 2003? Alright. Well, 2003 is 13 years from 1990, so what we want is P of 13. P of 13 is 190 times 13 plus 4170, which equals 6640. Now here's another way to check to see who's right here, because if I'm wrong about this function and the book is right, then you wouldn't get this result. Alright, you'd get another result, but the answer in the book reflects this result, which means that the author, or whoever it was that put the book together, made a typographical error. Alright, they probably saw that and were focused on that, and then they wrote that there, whoever it was. Okay, those things happen. So, because they put a 4360 there at the end, alright, in the book's answer. So, yeah, if it was 4360, you wouldn't get this answer, which is the correct answer, and which also is in the book. Alright, that's the answer in the book as well. Okay, so there you go. Okay, 51. The Federal Helium Reserve held about 16 billion cubic feet of helium in 2010 and is being depleted by about 2.1 billion cubic feet each year. I didn't even know we had a Federal Helium Reserve. I've heard of the Federal Oil Reserve, but not the Helium Reserve. Interesting. So let's see. Part A. Give a linear equation for the remaining federal helium reserves, capital R, in terms of lowercase t, the number of years since 2010. All right, so part A. So we're going to let, like they said, let R, capital, equal billions of cubic feet of helium. If we let it represent billions, that'll simplify things. Billions of cubic feet of, oops, I was thinking of helium there, so I wrote an H. Okay, going back here, of HE. That would be in the federal helium reserves. Okay, so now we have a point TR. We have a point TR, which is 0.16. So that's the number of years since 2010, 0. So in 2010, it had there was 16 billion cubic feet of helium. All right, and the slope m is equal to negative 2.1. Okay, so that's depletion of the helium by 2.1 billion cubic feet each year. That's what that represents. So it's being depleted, it's going down, so it's a negative slope, right? So hence the negative sign. So we use the point slope equation for a line. We've got a point and a slope. So the point slope equation, r minus r1 equals m times the quantity t minus t1. All right. So we've got r minus 16 equals negative 2.1 times the quantity t minus 0. And so that equals negative 2.1 t. That's it. You can just add 16 to both sides, so you get a function r of t is equal to negative 2.1 t plus 16. All right. So that's part A. And then we've got part B. So in 2015, what will the helium reserves be? So that's 5 years after 2010. So that means t equals 5. So we've got r of 5. That's negative 2.1 times 5 plus 16. So that equals 5.5. And that stands for 5.5 billion cubic feet of helium. All right? 5.5 billion. Everything's in billions of cubic feet. So if the rate of depletion doesn't change, in what year will the federal helium reserve be depleted? All right? So here we set r of t equal to 0. All right? And then we solve for t. So what's r of t? It's negative 2.1 t plus 16 equals 0. And now we solve for t. So 16 equals 2.1 t. Adding 2.1 t to both sides, or think of transposing this negative 2.1 t to the other side, changing the sign. And so you divide now both sides by 2.1, and you get t is approximately 7.6. Alright, so what's 7.6 mean? That's 7.6 years after 2010, which is 2017.6. So somewhere almost a little over halfway through 2017 is when the federal helium reserve will be depleted if this model remains the same. All right. Okay, number 53. You are choosing between two different prepaid cell phone plans. The first plan charges a rate of 26 cents per minute. The second plan charges a monthly fee of $19.95 plus 11 cents per minute. How many minutes would you have to use in a month in order for the second plan to be preferable? Now, at first glance, you might think the first plan is preferable because it doesn't have a monthly fee. It's just cents per minute. But these represent straight lines, and they're not parallel, so they do intersect somewhere. And where they intersect is where they're equal in cost. And so one of them is going to be less than the other. All right, and so we'd like to find out when the second plan is going to be cheaper. So what we need to do is get functions for the two plans. So we're going to first define your variables. That's important in math. Define your variables. So we're going to let capital C equal cost in dollars. Cost in dollars. And T equal time in minutes. Time in minutes. All right. So let's look at plan 1. Get a function for that. This is just 26 cents a minute. So C of T is equal to $0.26, or just 0.26 times the number of minutes. All right. So in other words, you can check your function. If you use 1 minute, just let t equal 1. 1 times 26 cents is 26 cents. That's what it's going to cost you for 1 minute. So that seems to work right. Let's look at plan 2. So we've got C of t is equal to, what does it say, 11 cents a minute plus a flat monthly fee of $19.95. All right, so that would be 0.11 t. There's your 11 cents a minute. And plus $19.95. So if you use 1 minute, let t equal 1, you're going to pay $19.95, the flat fee, plus 11 cents. All right, times 1 is 11. And if you use 0 minutes, you're just going to pay 0.11 times 0, which is 0, plus $19.95, or just $19.95. So that one makes sense. So what we want to do is set plan 2 less than plan 1. When is plan 2 cheaper or less than plan 1? So you can set up an inequality like this. And then plug in the functions. So we've got 0.11t plus $19.95 less than 0.26t. Alright, so now you just solve this just like any other inequality. Alright, so you can subtract 0.11t from both sides, or move it to that side and change the sign, and then just leave the $19.95 on the left side, so you get $19.95 is less than, and 0.26 minus 0.11t is 0.15t. Divide both sides by 0.15, and since you're dividing by a positive number, you don't have to worry about changing the direction of the inequality. So if you were dividing by a negative or multiplying both sides by a negative, you would have to switch the direction of the inequality. All right, so don't have to worry about that here. Divide both sides by 0.15 and you get 133 is less than t, or another way of putting that is t is greater than 133. All right, So this tells you if you use more than 133 minutes, then the second plan is cheaper than the first plan. And you can check that. Plug in some number like bigger than 133. 134, try that. Check it in both plans, see which is cheaper. Alright, and you will find that this is absolutely the case. Number 55, our penultimate question. Penultimate question, alright. When hired at a new job selling jewelry, you are given two pay options. Option A, base salary of $17,000 a year with a commission of 12% of your sales. And option B, base salary of $20,000 a year with a commission of 5% of your sales. So, how much jewelry would you need to sell for option A to produce a larger income? Alright, so we want to find out, this is similar to the previous problem, find out where option A is greater than option B. Okay, so we need functions first for A and B. So we're going to let I this is kind of unorthodox. I is usually stands for the identity function, but I'm going to take a few liberties here. All right, let I equal income in dollars. All right, and X equal jewelry sales. Alright, so that's going to be in dollars as well. Okay, so for option A, we have I as a function of X equals 0.12x plus 17,000. Okay, so double check me on this. Option A, base salary of 17 grand, right there. That's a constant being paid to you. And then your base salary, 17 grand a year with a commission of 12% of your sales. So there's your 12% or 0.12 of your sales X, whatever that is in dollars. Alright, so there's function A. And for B, we've got I of X is equal to 0.05 X plus 20,000. So again, option B, there's your base salary of 20,000. That's going to be there whether you sell much or not, and that's going to be your commission. Okay, so 5% or 0.05 of your sales X. All right. So where is or when does option A get bigger than B? All right. So we set A greater than B, or 0.12x plus 17,000 greater than 0.05 x plus 20,000. Alright. So we can subtract 0.05x from both sides and subtract 17,000 from both sides. Or you can think of moving this to this side and changing the sign to a negative 0.05x, and move that to the right side and change the sign to negative 17,000. So what you get is 0.12x minus 0.05x is 0.07x. 0.07x is greater than, and then you've got 20,000 minus 17,000 is 3,000. And then divide both sides by 0.07. That gives you X is greater than, and here's our sales, $42,857.14. So if your sales are greater than that figure, then option A is going to be the one you want. Alright, the last one, the ultimate last problem. Alright, when hired at a new job selling electronics, you are given two pay options. Option A, base salary of $20,000 a year with a commission of 12% of your sales, and option B, base salary of $26,000 a year with a commission of 3% of your sales. How much electronics would you need to sell for option A to produce a larger income? Alright, this is very similar to the one we did just previously, 55. So we're going to use the same variables. Alright, I is going to capital I is representing income in dollars, and lowercase x, electronic sales in dollars. Alright, so I'm not going to bother to write that down. It's the same as 55. So let's get a function for option A. Capital I of x is equal to 0.12x plus 20,000. So check me on this. Alright, option A, there's your base salary of 20,000 and a commission of 12% of your sales, 0.12 times x. Alright, and then we have B, I of x equals 0.03 x plus 26,000. So the base salary, there's your base salary, 26,000 a year, and the commission is 3% or 0.03 times your sales. Alright? Okay, so we want to know when option A is going to be better than option B. So set option A greater than option B and solve for x. Alright, so you got 0.12x plus 20,000 greater than 0.03x plus 26,000. And now what you can do is move this to this side, change it to a minus 0.03x, and move that to that side, change that to a minus 20,000, and then add like terms. Okay, so you've got 0.12 minus 0.03x, and you get 0.09. 0.09x is greater than, and then we've got 26,000 minus 20,000 is 6,000. Then you divide both sides by 0.09. That gives you x is greater than, alright, $66,666. And actually it keeps going 666666. Alright, so we'll just round it off to 67. Alright, there we go. I could make a joke about that, but I'm going to refrain. So that's it. It's been real. And it's been fun. Alright, especially the complicated problems we did in the beginning of this section. Wow, those were massive, big problems, and that was fun though. You know, I enjoy doing these non-routine problems, alright, with you. So, hey, I hope you can relax a little bit now and break out something to eat or drink and pat yourself on the back for a job well done. Do that anyway, alright? And I will see you in the next section, and that promises to be pretty interesting. Alright, we'll see you later.